Today's video will demonstrate the UML class diagram of the unordered set. Hello, I'm James Helfrich. The unordered set is built with a hash table. This video will demonstrate how to build your own unordered set, and it'll do so by explaining the UML class diagram associated with it. The UML class diagram for the unordered set is quite complex, so we're going to walk through it very slowly. Now we're going to begin with an empty class diagram. The name, of course, is the unordered set, and pretty much all containers have a collection of constructors. We'll have the default constructor, the copy constructor, the move constructor, the initializer list constructor. There's many. Assignment operators, once again, there'll be several assignment operators in clear. We also need to have empty and size, which means we must know how many elements are going to be an unordered set. And so we're going to need to have a num elements member variable, which can be a form of integer. It's probably going to be a size t. And we're going to have to insert and erase elements from an unordered set, which means this unordered set class is a template class. So we're going to specify that with a t in the upper right-hand corner. And t is going to refer to the data type of each element that we will put in our unordered set. Now we're going to have a begin and end, which means we're going to need to have an unordered set iterator, and this is going to be a nested class. So this is a public nested class, which means the client can instantiate a unordered set iterator. Now we're going to have erase and find, which will also return iterators, okay? And then we're going to have a collection of methods which are unique to the unordered set. Reserve, rehash, bucket count, bucket size, load factor, and max load factor. The functionality of each of these is non-trivial, and we'll get into those later, but we need to realize this is going to reveal some implementation details. Namely, we're going to have a collection of buckets, and each bucket is going to have a collection of t's according to the hash value. Now, the vector is related to the unordered set with association. Now, the association is composition because the unordered set will create and destroy the vector, and there's always exactly one vector. Now, I need to emphasize that the t in the vector is not the same as the t in the unordered set. And the reason for that, because every element in the vector is actually going to be a list. And this list is going to be associated with a vector, but that association is composition, and there will be many lists, one for every element in the vector. The list itself is going to have a pointer to the head node, and I'm not going to show the node in here because it's just going to add too much complication, but the important thing to realize is there's going to be a collection of t's, and that collection is going to be associated by composition, and there's going to be many t's in the list. Now, the t of the list is actually the same as the t of the unordered set, but the t of the vector, like I mentioned earlier, is not the t of the unordered set. It'll be a list. Okay, so now that we've outlined the basic mechanism in which the unordered set stores things, this can be basically a vector of lists. Do we have enough information to implement reserve, rehash, bucket count, and all that? Well, there's still one item missing, and that item is we need to have the load factor. And the load factor will tell you the average number of elements in each bucket. And we can manipulate that, which will help us to tune the performance of the unordered set. Basically, the smallest the max load factor, the higher the performance, but the most wasted space. Okay, so let's go back to the interface of the unordered set. We also have a hash function, an equals predicate, and allocator, which means there's not one template variable for the unordered set. There's actually going to be four. And additionally, we have two more public methods which are important. We're going to have a begin and the end. Now notice the begin and end here take an I index as a parameter, which makes it different than the begin and the end we had before. Now the standard begin and end returns an unordered set iterator. The begin I and the end I don't return a lit iterator, but rather a local iterator. And this local iterator is a nested class within the unordered set, just like the regular iterator. Now, what's the difference between the iterator and the local iterator? The iterator will iterate through all elements in the unordered set, whereas the local iterator will only iterate through a single bucket. Now, recall that each bucket is a list of t's. Now, that list, of course, is going to have a list iterator, which is going to be a nested class within the list, and the local iterator is going to have exactly one attribute, an it list, which is a list iterator. So there's going to be association between the local iterator and the list iterator. And that association is composition because the local iterator will create and destroy exactly one list iterator. Okay, so let's go back to the regular iterator. The local iterator is really simple because I'm iterating through a single bucket, but the unordered set iterator is more complex because it also has to jump between buckets. And remember, I store my collection of buckets with a vector, and that vector is going to have a vector iterator, which is a nested class. So how is the unordered set iterator going to use the vector iterator? Well, I'm going to have two attributes, an it vector and it vector end. The it vector shows me which bucket I'm currently in with my iterator, and the f vector end will show me when I end. And I need this it vector end for a kind of a subtle reason, because I don't have one with my local iterator. And let's figure out why that's the case. All list colon colon ends are the same. Why? Because they're the null pointer. But all vector colon colon ends are not the same, because the vector colon colon end is going to refer to the first element in the vector that's off the end of the collection. Therefore, because every vector iterator end is different, I must have an it vector end so I can know when to stop iterating through my buckets. And of course, the relationship between the unordered set iterator and the vector iterator is composition. And how many am I going to have? Exactly two. One for the it vector and one for the it vector end. Now, the it vector is not sufficient for me to know where I am in the unordered set. It just tells me which bucket I'm in. I also got to know where in the bucket I am for a given element of my iterator. Therefore, I need a third attribute, and that is it list, which is going to be a list iterator, and it's going to be associated to the list iterator through composition, and there's always going to be exactly one. Phew, that is a super, super complex class diagram, isn't it? Most of the complication arises, of course, from having a vector of lists and, of course, having two iterators. We can learn more about the implementation of the unordered set in the implementation section of the hash chapter of the C++ data structures textbook.